Time to add yet another segment to our OSPF network, and this is going to be another broadcast segment between routers 3 and 4 on the 172.12.34.0/24 network. We're going to add them to our OSPF network in area 34. So we continue to grow. Router 3 now is going to have 3 separate OSPF adjacencies, and I've already tested the connectivity between routers 3 and 4. We're ready to go there. So apparently I didn't test whether that was slid over or not. And I'll just send one more just in case. 34.3, and we're good. So I'll start over here on router 4. I'll try 34 there. We'll go with area 34. Same on router 3. And if history repeats itself, the adjacency won't take long. And by golly, before I could finish talking about history repeating itself, it did just that. Routers 3 and 4 now have their adjacency over that segment. And let's go ahead and just run show IP OSPF neighbor just for fun. And you see a couple of adjacencies to router 1 and one adjacency to router 4. And we can also see from here that router 4 has been already elected as the designated router. We see the expected dead time, the address, the Ethernet interface. We see all of that. And that was Ethernet 0. So we're looking at a broadcast type network. Here's the RID, here's the IP address, everything we've been seeing with this command so far. And remember, when you see the neighbor count down here, it's going to be the neighbor count off of the interface that I named here. So we can also see here 4 is the DR, and we're good to go there. So everything looks really good. Let's go down to 4, have a look around. See the one adjacency we expect to see. And by now we see that router 4 has routes to the segment connecting routers 1 and 5. It's got a route to the network connecting 1 and 3 through the direct connection, the point-to-point. And then finally that last route, 172.12.123.0, is our NBMA network. All of them are listed as inter-area routes. So we're not going to ping every single address here, but we'll ping the farthest ones, 123.2 and then 10.115. And we're looking good there. So now every other router in the deployment should have a route to the network between routers 3 and 4. And we see one, so there's 172.12.34.4, no problem. We go down to router 2, we'll do the same check there. Again, always a good idea to be checking this kind of thing as you go along instead of waiting until the end. So everything's looking really good so far. We've got some values in these routing tables we're going to revisit and look at. But the thing is, we've got the routes, we've got the pingability, and we like that. So what we're going to do now is something I promised you a couple videos back, and that's to add the loopbacks that are on every single router to our OSPF network. So you see we're going to get even a little larger, and you can also see why I did not put the interface types here in the diagram. We're starting to run out of space. What we'll do, and I'm actually going to pause the video. There's no use in you watching me enter 5 network statements. You know how to do that. I'm going to be using all zeros wildcard masks here. And that's because our loopbacks, when I created them, are all /32s, 1111/32, etc. And I'm going to put them in their specific areas that go along with the router number. So the loopback on router 1 goes in area 1, on router 2 goes in area 2, and so forth. So we got quite a few areas here, and we'll check everything out. Let me pause the video, and I'll go ahead and get those statements in for us. And that really didn't take all that long. I didn't need to pause the video, but just to show you that I am up to neither hanky nor panky, here is the config on router 1. Here's the config on router 2, again using all zeros in my wildcard mask to match that address and that address only. Router 3, here's the command, area 3. That voice sounded like an old elevator operator. 3rd floor, ladies' lingerie. Router OSPF 1, network 4, all wildcards, area 4. And router 5, everything's in area 5, or actually that one address is in area 5. So everything's looking good there. While we're on router 5, let's go ahead and start having a look around. We didn't have any new adjacencies, so we don't have to check those out. And our tables are getting larger and larger. So we see 3 loopbacks. How many loopbacks should we be seeing right now in the OSPF table? On each router, we should be seeing 4, because one of them, of course, is going to be connected to whichever router you look at. So that's kind of odd. Let's go ahead and just send a couple of pings around here. And we can ping these perfectly fine. And can we still ping the segment between routers 3 and 4, the 34 network? Yeah, it's looking good. So that's kind of odd that we don't have router 4's loopback here in our router 5 routing table, because we can revisit here and I do have the right command. And you know what could happen is that I forgot to put loopback 4 on router 4. So let's go check that out. We're on 4. And there it is, you know, IP address 4444/32, exactly as we expect. And sorry for that pause. Apparently Richmond International is rerouting airplanes very close to the top of our building. So we've got router 4's loopback is here. I'm not trying to trick you with anything there. We've got the IP address. We have the network statement. So let's go ahead and check out some of our other routers and see what we have. And router 1, as far as OSPF segments goes, it only sees 3 loopbacks, and it should be seeing 4, and the same one is missing. So we're starting to get a bit of a pattern here, unlike the pattern of that jet going over our building. And here with router 2, we see a few more OSPF routes, which we expect, but we see 3 loopbacks. We don't see 4. Well, how about 3? Because, I mean, router 3 is literally neighboring, adjacent to router 4. And router 3 doesn't see it either. Wow. So none of the routers right now see router 4's loopback. I mean, router 3 is super adjacent to router 4. So what exactly is going on here? You've likely already doped it out, but it does go back to that question that I've asked a couple of times about the different areas as we were building them. You know, are we going to have a problem here with the rule of the physical or logical connection back to area 0? Well, I didn't ask it after these 5 areas, but now we're running into a problem because area 4 does not contain an interface on a router that also has a physical or logical connection back to area 0. Router 4 doesn't have an interface in area 0, and it's the only router that has an interface in area 4. So this is what I was talking about, and I know I've mentioned it a couple times, but the reason that I really want to bring this to your attention is that notice that everything else is perfectly fine. We didn't get any kind of message from the router on router 4 when I did that network command saying, hey, you're violating this rule. We didn't get anything like that. And when we went to all of the other routers and looked in the routing tables, it's not like we didn't get any console messages, any warnings, anything like that at all. And we were able to ping all the other loopbacks. So this is, you got to watch this rule, because when we violate certain other rules in Cisco land, let's face it, you know, the router tells us or the switch tells us, you know, hey, did you know this? Or you run a debug and you get something. I could have debugged this to death and I really wasn't going to see a problem. But the issue right now, again, is area 4 on router 4 is violating that rule. And if we can't have a physical connection back to area 0, which it would be hard to do right now, then we could create a logical one. We've created plenty of physical connections, but what I want to introduce you to coming up next is what we call an OSPF virtual link. And that should resolve this issue. And the configuration of the virtual link is pretty simple, frankly. It's spotting the need for it, which is what we did in this video, that can actually be a little difficult. Because you might even go a little while in another lab, let's face it, and look at that, and not even notice that router 4's loopback isn't being successfully advertised. But now that we've noticed it, in the very next video, at the very next beginning of the next video, we are going to fix that situation. I'll see you there.